Welcome back. This is Dr. P.A.Hagargi from SVERIs College of Engineering. Today I am going to deliver a video lecture on generation of symbol table for a language. Symbol table in compiler. Before that, let us have a prerequisite of the symbol table in a compiler. Let me move on to the phases of the compiler to understand about the symbol table. The phases of the compiler, as we know that lexical analyzer we have, and syntax analysis, semantic analysis. Here we have syntax analysis, semantic analysis, then intermediate code and code optimization and target code. As these are the 5 phases or main important 5 phases in a broad way, we are just telling here. Lexical analyzer, syntax analyzer, semantic analyzer, then intermediate code and code optimizer and target code. So these are the phases of the compiler. Among these phases of the compiler, when do we require the symbol table? As the symbol table stores all the entries of the program, in the symbol table, as and then those entries or those variables which are required in the program, as and then whenever they are required, they are called for the computation by the compiler, or called in the sense they are set the pointers to call back them and substitute their values for the execution of the program or for the computation of the program's logic. So let me brief you once again. Lexical analysis creates a new table entries in the table. Examples like entries about the tokens. Those entries, what I was saying about the variables, those are nothing about the tokens. As the syntax analysis adds the information regarding attribute type, scope, dimension, line of reference, and their use, etc. in the table. What the syntax analysis will do? Syntax analysis creates the table entries in the table, like it makes the entry of the token, and syntax analysis adds the information regarding the attribute type, its scope, dimension, line of reference, and their use and etc. in the table. Semantic analysis uses available information in the table to check for semantics, in the sense to check for its meaning, to verify that expression and assignments are semantically correct, like for type checking, and update it accordingly. In intermediate code refers the symbol table for knowing how much and what type of runtime is allocated, and the table helps in adding the temporary variable information. Code optimization uses the information represent in symbol table for machine dependent optimization. I hope you have understood here. Code optimization uses the symbol table it uses the codes present in the, it uses the tokens, whatever is or entries or the informations present in the symbol table for machine dependent optimization. Let me recall here who was the machine dependent. Like Java was the language, and they themselves generate the bytecode. So for the Java is said to be as a language which is a machine independent, and here like C and C++, these are called as machine dependent. So they don't have bytecode, they have the target code generation, and they make use of the entries present in the table. And target code generates using the address code information of the identifier present in the table. Here let me brief you lexical analysis. What does it does? It makes the entries of the tokens. And syntax analysis, it specifically adds the informations like it specifically adds the informations like the attribute type like integer or float type, and their scope within the local within the program, like locally or globally declaration, and their dimensions, that is 1D or 2D, what about its, and line of reference like the memory allocation reference, and use and etc. in the table. Semantic analysis, analysis, what it is, it uses the available informations from the table to check for the semantic, that is to verify the expressions and the assignments are semantically correct or not. They do the type checking and update it accordingly. Type checking in the sense error checking, and checks the error and come back and holds once again, updates those corrected values or the corrected variables or corrected tokens in the symbol table. And intermediate code generation refers the symbol table for knowing how much and what type of the runtime is allocated. Intermediate code, what does it does? As we know that what the intermediate code is nothing but the tree address code. Tree address code is nothing but this further helps for the code optimization. So therefore here what the intermediate code does in the symbol table, it refers the symbol table for knowing how much it takes the time for the program to run, or what is the runtime execution time allocated, and the table helps in adding the temporary variable of the temporary variables used in the program. So because they are entered in the symbol table, as the compiler moves for the code optimization, it makes use of the informations present in the symbol table for machine dependent optimization. Machine dependent optimization here for the target code generation. As the target code generates the code using the three address informations of the identifier present in the table, whether it is a Java type of the code or whether it is some other type of the code. So based on the type of the code, it generates the target code generation. If it is a Java type, means it is a machine independent, so they generate the byte code. It depends on the language. So based on the language, the compiler generates the target code. Let me move on. As I briefed here, the prerequisite of the compiler was required here to know a lot more on the symbol table. The symbol table is important data structure created and maintained by the compiler in order to keep track of the semantics of variable, that it stores the informations about the scopes and binding. Information about names, like names, information about like instance of the variables, entries such as variables and functions, names, classes and objects are made, and these are nothing but the items which are stored in the entries of the symbol table. It is built in lexical and syntax analysis phase, and this information is collected by the analysis phase of the compiler and is used by the synthesis phase of the compiler to generate the code, that is to generate the final target code. It is used by the compiler to achieve the compile time efficiency. It is used by the compiler, here we make note, very important point, it is used by the compiler to achieve the compile time efficiency, because every time if the same variables are frequently used, so it need not to go back in the memory and check for the variable and make use of that variable. So here what does it does, Once the entries are made in the symbol table, so here the pointer goes back, pointer goes only to the symbol table and checks, takes the updates of those variable and come back and evaluate those variables values, or according to the sign off, or according to the token generated in the symbol table. So make accordingly that the program logics executes. So here I have made the prerequisite why we need the lexical analysis. What is the backend story of the symbol table, making use of, by making use of the symbol table, where the symbol table makes the sense and the importance in the several phases of the compiler. As the symbol table entries, each entry in the symbol table is associated with attributes that supports the compiler in different phases. As I said, they themselves have made the very important phases in the respective phases of the compiler. So the items stored in the symbol symbol tables are what, like say for example variable name and constants, procedure and functions names, literal constants and strings, compiler generated temporaries, labels in the source languages. So these are the items stored in the symbol table. What the items like variable names and constants, everything other than the basic building block of the program, other than the basic building block of a language, other than the basic building block of the. So these are the items what the programmer make use of. These items make use to do the, or to develop the logic of the program. So those all the items are stored in the symbol table. Like variable names, most generally, like variable names, constants, procedures, functions, literals, constants and strings, and compiler generated temporary variables, labels in the source languages. So these are the items which are stored in the symbol table. Informations used by the compiler from the symbol table. What informations are used? The same informations what is being stored in the symbol table, like data type and name, declaring the procedures, and offset in storage. If structure or record, then pointers to the structure table. If the parameters, whether the parameter passing by value or call by reference, so it also makes that entry also, and number and type of the argument passed to the function, and base addresses also. These are the informations which are the compiler make use of the symbol table, like data type and names. It makes the column of data types and names, declaring procedures, and offsets in the storages, what the offset value is holding a particular line, and if the structure or the record or pointer to the structure table, and whether the parameters are called by value or called by reference, and number and type of arguments passed to the functions, and base address. Now the operations of the symbol table, the basic operations defined on the symbol table include the operations like allocate into the symbol table and free the symbol table, and also a lookup is required to search that particular variable, or that particular call by value, or that particular function or particular procedure, so that it calls it calls, or it points from this symbol table to, and go back to the program, and again go back to the program, and insertion is required, and set attribute. This is an association to an attribute with the given entry, and as set attribute and also get attribute. uh, before setting the attribute, so we require another function, that is the get attribute. So these are the functions which are required. That more deep into that, to allocate a new empty symbol table. Allocate is to allocate a symbol table. So make a memory of it. allocation of the symbol table. And as we do allocation, once the symbol table is utilized by a particular program, when there is no more usage of that symbol table, so we can free it. So to remove all the entries from the symbol, to remove all the entries and free the storage of the symbol table. And look up to search for a particular name and return the pointer to its entry, and return the pointer to its entry. And once again here I will tell what about the insert. To insert a name in a symbol table and return a pointer to its entry, and return a pointer to its entry into the program. And set attribute to here a relationship to associate an attribute with a given entry. A association, or to associate an attribute with the given entry. To associate an attribute with the given entry. So how is that association? What is its relation? So to associate an entry with a given to associate an attribute with the given entry. So to set an attribute we require get an attribute. So to get an attribute, the same attribute, to get an attribute, so we require a function get attribute. To get attribute, to get an attribute associated with a given entry. So what is a symbol table? It makes you symbol table is nothing but an entries of the program. Like what the entries, except the basic building block of a program, except the language code, what the items are required to construct a logic, all these are fed, or all these are stored, or all these are nothing but the entries of a symbol table. So what the how the implementation of the symbol table is done. So there are different methods of implementing, that is list, linked list, hash table, and using the binary search table. So implementation of the symbol table is done by the following common data structures for implementing the symbol table, by making or by developing, making use of the how a symbol table is constructed or developed, by making use of the data structure called as list and linked list, and also it can be implemented using the hash table, and also it can be implemented using the binary search table. This is how the symbol table. What is symbol table? A symbol table is nothing but it makes entries of all the items of the program, that is like data type, name, and variables, procedures, literals, constants. These all are nothing but stored in the symbol table. As and then whenever they are required by the program, they are making a pointer, make the pointer to that entry and again come back. Make the pointer to that entry and again come back. Give its value and come back, or substitute that whenever it is required in the program. These are nothing but the entries of the symbol table. These are nothing. So thank you. This was the video on this symbol.